Hey YouTube, it's AI Enigma here. So this is our 10th session in Road to Cat LRDI series. This set is definitely a harder difficulty set, both because of the logic it involves in solving the set and the representation it involves for extracting the data and making a suitable representation so that you can understand the gist of it. So as usual, I will provide the link of the session and the PDF of the session in the comment section below. You can access through that, try the set yourself, and then look at the solution. So let's get cracking. So a survey was conducted among three groups of professionals, doctors, teachers, and engineers, regarding the number of days off they believe would enhance their work efficiency during a week. Participants were allowed to choose their preference among 1 day off, 2 day off, 3 day off, or opt out of the survey. So far, it seems to me that some people are opting for a survey and they can choose either 1 day off, 2 day off, 3 day off, or they can choose that they are not opting for a survey. These three professions are doctors, teachers, and engineers. It is assumed that a person who prefers 2 day off also prefers a 3 day off, which means 2 is a subset of 3. The person who are preferring a 2 day off also preferring a 3 day off. And it's been also been noted that and someone who prefer 1 day off also prefers both 2 day and 3 day off, which means 1 is subset of both 2 and 3. This is the kind of key crux of information that is given. However, the reverse is not necessarily true. Okay, so this looks like to me a Venn diagram set, and in Venn diagram set also we have three distinct parts. One is of a doctor, one is of a teacher, and one that of engineer. Let's get further and then we will realize what the set is saying. A total of 25 males participated in the survey, while a higher number of females participated across the three professions. Now there comes a little bit of problem, is that this is just not doctors, teachers, and engineer. This has to be further bifurcated into males and females. Now this causes a bit of strain to us because this makes the Venn diagram a lot complicated, because not only we have one preference of 1 day off, 2 day off, 3 day off, and those who are opted, like, no, we don't want the survey. Then we have, on to that we have doctors, teachers, and engineer, and then also we have male and female. So this becomes a lot complicated if you are trying to deal with Venn diagram, with the way of Venn diagram. So how do we solve this? The best way to solve this kind of set representation is by cumulative bar graph method. Now what do we mean by cumulative bar graph method? Because we know that a person who is preferring 2 day off also prefers a 3 day off, which means in 1 day off, 2 day off, and 3 day off, onto the 1 day off, if we add some kind of value x, the persons who are having or preferring a 1 day off, if we add some kind of value x to it, we will get the value of the persons, or we get the number of person who are opting for 2 day off. Similarly, onto the number of person who are having 2 day off or preferring 2 day off, we add a value to y, we will get the number of person who are opting for 3 day off. So this is a clear cut, if you remember, cumulative bar graph. In cumulative bar graph, let's say if there is a test and 10 people answers the question of the test, on to the next 20 people answered the question. So instead of writing 20, I would just write 30. And on to the next test, if 20 people more answered the question, then instead of writing 20, I will just write 50. And on to the bean, we remember that 10 persons are answering this test, 20 people are answering these questions, and 20 people are answering these questions. So this is the way of the cumulative bar graph works. And we can also, rather than cumulative bar graph, we can make a table out of it. And instead of 10, 30, and 50, we will write 1 day off, 2 day off, and 3 day off, because the logic is pretty much the same. Because we know that a person who is opting for 2 day off also opts for a person who has have preference for 3 day off. That's the kind of logic that we're going to use in order to crack this set. Okay, so this is specifically clear. So what I will do, I will make a table in which I will make a column of for 1 day off, 2 day off, 3 day off, and for not opting for a survey, because that's also an option that's been given to us. Either they choose 1 day off, 2 day off, 3 day off, or opt out of the survey. And then I will make three professions, that is doctors, teachers, and engineer, and total as well. So this would be one table for males and one table for the female. That would be my way of representation of this set, and it would be like this. And the left table here belongs to the males, and the right here belongs to the females. That would be the representation for this set. After that, what I will like to do, I will like to extract this full information to the next page so that I don't have to revisit this page once and once again and again. A total of 25 males participated in the survey. Okay, so we have a total of 25 males who have participated in the survey, while a higher number of females participated across the three professions. Among the male participants, there were 3 doctors, 5 teachers, with the remaining being engineers. So we have 3 doctors, 5 teachers, that's total 8, so 17 being the engineer, that is the value that is being given to us. Okay, so that's specifically fine to me. Then we have the number of female doctors was 4 times that of male doctors, and the number of female teachers was 5 more than the number of male doctor. So the number of female doctors is 4 times the number of male doctors, which means this value becomes a 12, and number of female teachers is 5 more than number of male doctor, which means this value becomes an 8. So that's the key crux of information that was known to us. Now on to it, I will utilize these 5 points so to crack the set. All males and 75% of females prefers 3-day off. Now what do this means? First thing is that you have to remember our Venn diagram that we draw. In our Venn diagram, we make 1 day off, 2 day off, and 3 day off. That was the kind of characterization that we made. If you remember, 1 was subset of both 2 and 3, and 2 was a subset of 3. Now the question is saying all males prefer 3-day off, which means all the males are preferring 3-day off, which means there is no one outside the Venn diagram, which implies here that there is no one who is not opting for the survey. So this value becomes a 0. Similarly, 75% of the female prefers 3-day off. So if total number of females is x, so 0.75x females are preferring 3-day off, accordingly to which we can assume that 2.25x females are not opting out of the survey. So first point is definitely done. Then we have 45% of females prefer 2-day off. So this is 0.45x of females prefer a 2-day off. Female engineers preferring 2-day off are 26% of total females. So which means this value is 0.26x. That's specifically given to us. Now, if I subtract 0.26x from 0.45x, we would get the value here as 0.19x. And if I assume this value to be a, for example, this becomes 0.19x minus a. So this is the first key crux of information that we are deducing. Then we have among males preferring 2-day off, among the males who are preferring 2-day off, 75% are engineers. 75% are engineers. So 2-day off, let the number of males who are preferring 2-day off to be b, then 75% are engineers, which means this value becomes 0.75b. And then we can assume that this value, since this is, if we subtract this value from here, we will get 0.25b, and let's assume that this value is to be c, then this becomes 0.25b minus c. And since we know that this is a cumulative bar, cumulative table, which means the number of persons who are preferring 1 day off would also contain number of persons who are preferring 2-day off and 3-day off. So we can assume that this value is 3. The final value would be 3 because this is a cumulative bar, cumulative table. This value becomes a 5 and this value becomes a 17, and this total value becomes 25. Why I am writing this? Because number of persons who are opted out of the survey are 0, which means all the Venn diagram, all the Venn diagram all the values that will be inside the Venn diagram, there would be no value which is outside the Venn diagram. That's why I can immediately write this value to be here, because this is after all a cumulative table. So that's one thing that's specifically clear to us. Now the third point, among males preferring 2 days off, 75% are engineers. Among males who are preferring 2 days or 75% engineers, that's specifically clear to us. We have already utilized this information. Only one male teacher prefers 1 day off. So only there is one male teacher who's preferring 1 day off. So this value becomes 0, this value becomes 0, and this value becomes 1. So this is specifically clear to us. Then we have all female doctors and 3 female teachers prefer 1 day off. All female doctors, which means 12 female doctor, and 3 female teachers prefer 1 day off. 3 female teachers prefer 1 day off. Now, since we know that there are only 12 doctors and all of the 12 values are on 1 day off, so definitely there is 0 value of, there are 0 females who are opting out of the survey. And also we know, because this is a cumulative table, as I said, and this value, since it becomes a 0, this value 3-day must be 12. And since this is a cumulative bar graph table, so which means the persons who are opting for 1 day off is a subset of 2-day off and 3-day off. So if this value becomes a 12 inside, then this value also is a part of 3. So this value is also 12. So 2 must also be 12 as well. So this value becomes a 12. And since this value is a 12, we can rewrite this value and we can write this value as a 12 as well. So this is fine to me. Then we have doctors preferring 2 days off is equals to teachers preferring 2 day off. Now let's look at the doctors preferring 2 days off. So doctors preferring 2 days off are 3 plus 12. So doctors preferring 2 days off is 3 plus 12, which is equals to teachers preferring 2 days off plus 7. So we have teachers preferring 2 days off. Teachers preferring 2 days off is 0.25b minus c and 0.19x minus 12. This would be the value. So we have 0.25b minus c plus 0.19x minus 12, and this value is plus 7 as well, so I will add plus 7 here. Now there is a problem here. We have utilized all the information that we can, and we have got only one equation and there is 3 variables there, and we have to solve the set. Now what do we do in such kind of predicament? The first thing is that whether we missed something? No, we haven't missed something. So if you feel stuck like in this set, always look at the questions first. Now question says how many females participated in the survey. So there must be a way to figure out how many females have participated in the survey. So how do we figure that out? First, let's look at the doctor first. Like we have the total number of doctors that have participated in here, but the problem arises that there is no specific information here. So this is not helpful for us. If we look at the engineers, although we have 0.26x, but there is no number of engineers which been given to us, and in total there is either no number. So the only key crux of information that we have to find is this value. If you look at clearly here, we know that there are 8 teachers in total, and in those 8 total we have 3 teachers who are preferring a 1 day off. So bare minimum we have to remember that there must be 3 teachers who are also preferring a 2 day off. So the minimum value of 0.19x minus 12 must be 3. And similarly, the maximum value of 0.19x minus 12 can be 8. So which means I have the limits of this value, which means I can write 0.19x minus 12 greater than or less than 2. This value ranges between 3 and 8. That's specifically clear to us, because since we know that this is a cumulative table, you have to remember I'm stressing cumulative way too much because this is the crux or the essence of the set. If there are 3 teachers who are having 1 day off, then there must be a minimum of 3 teachers who are having a 2 day off as well, and maximum it can be 8 because of this value. So accordingly to it, if I say that 0.19x minus 12 has 2 values, the minimum it can be 3 and the maximum it can be 8. So if I rewrite this again, so we have 0.19x ranges between 15 and 20. Now if you remember this, 0.19x must be a integer, and it must ranges between 15 and 20. This is only possible when this value is 19 itself, and the only way that this value becomes a 19 when x is equals to 100, which means we have figured out the number of females who are actually opted for the survey, and this value is 100. So let me pick a color of blue. So this value becomes 100. This is 12 and 8. This is 20. So which means engineers are definitely 80. And since number of females that x is equals to 100, so this value becomes 25. This value becomes 45. This value becomes a 75. This value becomes a 26. And this is 19 minus 12. Then this value becomes a 7. Okay, so this is specifically clear. So this is the key crux of information that we are able to deduce from this point. Now what I will do, I will substitute this value x is equals to 100 into our key, you can say, equation, and then I will like to further reduce further what is actually going on. So I will erase all this since we have utilized this. Now I will rewrite this equation. We have c plus 12, which is equals to 0.25b minus c, which is still unknown to us, and we have figured out 0.19x minus 12 is actually 7. So this is nothing but 7 plus 7, which makes 14. So we have further clarifying this equation, we have when c comes here, so this would be 2c is equals to 0.25b, and then we have 14 minus 12, that is actually 2. So we have plus 2. So this is the key crux of information that we are able to deduce, that 2c is equals to 0.25b plus 2. Now one thing that you have to remember, that as we have done onto the female side, the males also, if you remember the value of c is ranging between 0 and 3, which means the value of c can be actually 4. It can be 0, it can be 1, it can be 2, and it can be 3. That is the range that 2c has. So if we assume the value of c is to be 0, if the value of c is 0, then the value of b comes out to be negative. which is not possible. So C is not 0. Can C is 1? Can C be 1? If C is 1, then 2C becomes a 2, which is equals to 0.25b plus 2. Then in such case, B becomes 0. But B cannot be 0 because B has to be some value, because it's known that, B person opted for 2 day off. So C cannot be 1 as well. If C is 2, then LHS become 4 and RHS becomes 0.25b plus 2. In such a case, 0.25b is equals to 2, and in such a case, B is equals to 4. This is possible when C is equals to 2. Let's check onto the table. If we write C is equals to 2 and B is equals to 4, so C is equals to 2 and B is equals to 4, then this value 0.25b, which we have written right now, 0.25b, let me check further. Okay, wait a second. So we will check B is equals to 4. Now we'll put B is equals to 4 and C is equals to 2 onto the equation of the males. So we will get the value. So we got the value of B is equals to 4 when C is equals to 2. So if we put C is equals to 2 and B is equals to 4, then this makes this value 0.25 into 4, then this is 2. So 2 minus 2 leads to the value of 0. But we know that this value is minimum 1. It cannot be value of 0 because this is a cumulative table, which means that value cannot be 0, and this also qualifies that C cannot be 2 as well, which means C has to be 3, which means this value is 3 into 2, which is equals to 0.25b plus 2. So this is 6 is equals to 0.25b plus 2, which is 0.25b is equals to 4, or in other words, B is nothing but 16, which means B is 16 and C is 3. So we will put this value. So C is definitely, this value becomes a 3, this value becomes a 3, this value becomes 16. There's some sort of thing going on. This value is 16. 0.75 into B, so we have 0.75 into B is 16. This value leads to the value of 12, and then we have 12 and 3, 15 is automatically done, so this value becomes a 1. So based on the information that's been provided to us, we have calculated all that we can onto this table, and based on this information we will try to solve the questions. So let's look at the questions now. First question is, how many female participated in the survey? So we know that 100 people participated in the survey, so the answer to the first question is 100. How many of the chosen people did not prefer 2 day off? So based on the total number of people are 125, and on those 125, 16 people prefers a 2 day off and 45 people prefers a 2 day off. So that's 61 people. 61 people prefer a 2 day off. So this means 64 people did not prefer a 2 day off. So the answer to the second question is 64. What is the minimum number of female who may prefer a 3 day off? Minimum number of females that may prefer a 3 day off is 75. They have a definite value. There is no minimum here. So this is 75. And we have, what is the ratio of number of male engineers who prefer a 2 day off to number of male doctors who prefer a 3 day off? Male engineer 2 day off, male doctor 3 day off. Okay, male engineer 2 day off is 12, male doctor 3 day off is 3. So we have 12 by 3. So the answer is 4:1. So I would say this is definitely a harder difficulty set based on the representation which is involved in this set, and the key crux of logic is not also easy to spot. So try it again if you're not able to understand it. Repetition is the only factor that you have to do in order to sustain the logic inside your brain.